All right, so I've connected this feedback resistor to this negative terminal over here. And if you can recall the classes for the gain, uh, I want you to think in your mind that what will be the gain of this op amp with the formula, right? For these type of non-inverting amplifiers. So just think about it and what should be your gain. So the answer for the gain for this circuit is going to be 2. Uh, I think you know the formula for the gain, that is 1 plus the feedback resistor divided by the inputting resistor, right? That's going to be 1 plus 1 over 1, which means that is 1, which is 1 plus 1 is going to be 2. So our gain for this circuit is going to be 2, and we will just visualize that with our outputs as well, right? So I'm going to add a voltmeter over here at this output junction, and I'm going to place the reference to the ground with the reference to the ground, right? And I'm going to observe what is my output based on all these parameters right side over here. We can go for the graph as well, but I think it's pretty straightforward that you just need to see a DC analysis right now. So it won't make any importance right now to look at the graph. So the value would itself be a DC value, right? So when I run this simulation, what I would observe over here is that I'm getting output of 10 volts over here, which makes sense. Your input is 5 volts. You have a gain factor of 2, which means your output by theoretical calculation should be 10 volts. And it's giving you the approximately near to that 10 volts, which is 9.97. Pretty good, right? The next thing that I'm going to do, I'm going to first stop the simulation. The next thing that I'm going to do is I'm going to make this 5 volts to 8 volts, I would say, right? So now again, a brainstormer, a question to all of you. What would you observe at the output? 8 times 2 is going to be 16, right? But the question is, what answer would you get at the output? You would not get a 16 volt at the output, because the thing is that over here you can see these values are the limiters or the saturation points, right? If it go beyond, output goes beyond 15 volts, then the output is saturated to just 15 volts. You won't get 16 volt or 17 volts, right? So let's try to run the simulation with the same configuration and same settings. And once I play that again, you can see it is going till 15 volts. Although by mathematical calculation or by theoretical knowledge, the 8 times 2 is 16. It should reach 16 volts, but no, it's being saturated at 15. Even if we go way beyond that, like for example, if I make it 9, just for the understanding, right? And I play the simulation again, 9 times 2 is 18, but over here you can see again it's going to saturate at 14 volts, right? So it's gonna the op amp is not gonna work beyond the applied voltages over here. So just for your understanding, what I'm gonna do, I'm gonna change this values from 15 to 20 maybe. So see if this circuit works fine now or not. All right. So I'm gonna play the simulation again. Now my applied voltage across this op amp is 20 volts positive and 20 volts negative. 9 times the gain 2 is gonna give me an 18 output. Now it should not saturate, and now it should reach the value of 20 as per the theoretical understanding. Let's see with simulation mode. As soon as I play the simulation mode, you can see that 17.9 it appears over here, which means that it's now 9 times 2, 18 volts. It's appearing over here. So that's the basic non-inverting op-amp circuit that you need to understand, and you need to understand what all those minute details over here, like resistors, the values of saturation areas means in any bigger circuit when we go ahead in the course, right? Um, with that being said, um, you have done with the video B. Provide your understanding on the results obtained and give brief circuit analysis. What I want you to is to just provide a basic understanding of what every parameter over here means. And task E will be interesting for you. You need to design